Why is there root multiplicity when the quadratic discriminant is 0? Imagine solving a puzzle where one piece fits perfectly into different spots. That's kind of what happens with roots in a quadratic when the discriminant is 0. The discriminant is a number that tells us about the roots of a quadratic equation. It is calculated as the square of the coefficient of the middle term minus 4 times the product of the coefficient of the squared term and the constant term. When this number is 0, it means the quadratic has exactly one solution, but it counts twice. This is called a root with multiplicity 2 or a repeated root. Now think about the quadratic formula, which is used to find the roots of any quadratic equation. It involves taking the negative of the middle coefficient, adding or subtracting the square root of the discriminant, and then dividing everything by twice the coefficient of the squared term. When the discriminant is 0, the square root part becomes 0. That means both solutions from the formula are actually the same number. So instead of two different roots, we get one root that appears twice. Root multiplicity is just a way to say how many times a particular root shows up as a solution. If a root appears once, it has a multiplicity of 1. If it appears twice, it has a multiplicity of 2. For quadratic equations, a repeated root means the factor associated with that root appears twice in the factored form of the equation. For example, if the root is r, then the quadratic can be written as a times x minus r squared. That shows the root r is repeated twice. Graphically, this is easy to see. The graph of a quadratic function is a parabola. When there is a repeated root, the parabola just touches the x-axis at one point and does not cross it. This point is also the vertex of the parabola, which is the highest or lowest point depending on whether the parabola opens up or down. This touching point is where the function's value is 0, and because the root is repeated, the parabola just kisses the x-axis. The reason the root repeats when the discriminant is 0 is because the quadratic can be written as a perfect square. When you factor the quadratic, it looks like a times x minus r squared. This perfect square form confirms the root r appears twice. So, algebraically, the 0 discriminant means the quadratic is a perfect square, and graphically, it touches the x-axis at exactly one point. Knowing this helps us understand how quadratic equations behave. When the discriminant is 0, the solution is unique but counts twice. It's like having one special point where the parabola just touches the x-axis and then turns back. This concept makes solving and graphing quadratic functions much clearer, especially when you see how the algebra matches what you observe on the graph.